example 3, we're going to write equations in standard form. So, we already know how to write equations in factored form, so all we're going to do is take these zeros and write them in a factor. So, this is plus 1, so when I write as a factor, it's going to be x minus 1. This is x minus 2, so when I write it in a factored form, it's x plus 2. And then this is a positive 3, so when I write it in a factor form, that's x minus 3. Okay, so now we have to figure out what standard form is, and basically standard form is we're going to get rid of all these parentheses. So yes, that means we're going to multiply. So x times x squared, x times 2, 2x, negative 1 times x, negative 1 times 2. And then to make it easier, I'm going to combine my like terms so I can combine those two terms. So I have x squared plus x minus 2. So that's when I multiply the first two together. And now I'm going to multiply that times x minus 3. X squared times x, x to the third, x squared times negative 3, x times x, x times negative 3, negative 2 times x, and negative 2 times negative 3. Last step, combine my like terms. X to the third, this is the only one, so it's just x to the third. X squared, negative 2x squared. Negative 3x, negative 2x, that makes negative 5x. And then this is by itself because it's a number, so it's just plus 6. So my equation in standard form is x to the third minus 2x squared minus 5x plus 6. And that's it. So now I'm going to look at example 4. In example 4, irrational root theorem. So basically, when we're using the quadratic formula, so we have negative b plus or minus the square root of b squared minus 4ac all over 2a. And basically, what I'm trying to explain is that when you use the quadratic formula, you should get two different answers, a plus and then a minus. So that's basically what the irrational root theorem says. When a polynomial with real coefficients has a root of the form a plus b times the square root c, then its conjugate a minus b times the square root of c is also a root. So basically, if this is a positive 2 times the square root of 3, another root we could have is the conjugate of it, which is a negative 2 square root 3. So we just have to have the positive version of it and the negative version. Okay? And now that we have our roots and we know that we have 3 roots, we have to write it in factored form first, and then we're going to write it in standard form. So factored form is just the same thing, x minus 5 for this, for a 0 of positive 5, and then for positive 2 square root 3, sorry, it's going to be negative 2 square root 3, x minus 2 square root 3, and then this is negative 2 square root 3, so that's x plus 2 square root 3. Okay. And so when we're multiplying out, it doesn't matter if you multiply the first two together or the last two together first. To make things a little bit easier, I'm going to get rid of the two parentheses that look the hardest and the ones that probably look a little more interesting. or harder is the ones with the square root of 3. So if we multiply those together first, the equation will get easier when you multiply these two parentheses times the x minus 5. So what I mean by that, and I'll show you, is x times x is x squared. X times a positive 2 square root 3 is 2 square root 3 times x. And then negative 2 square root 3 times x is negative 2 square root 3x. And then we have negative 2 square root 3 times a positive 2 square root 3. So that's going to be a negative. So when I'm doing 2 square root 3 times 2 square root 3, I am going to multiply those together. So I'm going to multiply the numbers that are outside of the parentheses, outside of the square root, together. So that's 2 and 2, which makes 4. And then I'm going to multiply the two numbers that are inside the square root. So that's 3 and 3. So 3 times 3 is 9. But I know that the square root of 9 is 3. So I just have 4 times 3, which makes 12. So that's a negative 12, sorry. So negative 2 square root 3 times positive 2 square root 3 is negative 12. Okay. Now I'm going to see if I can cancel anything out. And this is a positive 2 square root 3x. This is a negative 2 square root 3x. So I can cancel those out. So I just have x squared minus 12. And then I'm going to bring down this x minus 5. Okay. Now I'm going to multiply again. So I have x times x, x to the third. X times negative 12, negative 12, x. Negative 5 times x squared, negative 5x squared. Negative 5 times negative 12 plus 16. And that's it. My answer is x to the third, x cubed, minus 5x squared, minus 12x plus 60. Okay. And I can't combine anything, so that's my answer. So we're going to look at example 5. So basically the rational root theorem and the complex root theorem basically says the same thing. So remember, if a 0 is negative I or imaginary I, then also its conjugate or the opposite of a negative I is a positive I is also a root. And root means the same thing as 0, if you didn't know. So I'm basically going to take my zeros and write it in factored form, which should be pretty easy. So I have x plus 3, x, this is minus I, so when I plug it into a factored form, it's plus I, and then that's plus I, so that's x minus I. Cool. Okay. And to make things easier, it doesn't matter if you multiply the first two parentheses together or the last two parentheses together. I'm going to multiply the last two parentheses because these are imaginary and something magical will happen when I multiply them together. So basically xx is x squared, x times x is x squared, x times negative I is negative I times x, I times x is I times x, and then we have negative I times a positive I, so that's negative I squared. Now I'm going to combine my like terms. So I can combine these because these both have x's, negative ix plus ix. Those cancel. So I have x squared minus I squared. And so anytime you have I squared, that's going to equal to a negative 1. Okay. So when you have, So that's x squared minus, and then I squared is negative 1, so that's negative 1. The negative and negative makes a positive, so that's x squared plus 1. So now I'm going to multiply that times this x plus 3. So x times x cubed, x times 1, 1x, so you could just put x, 3 times x is 3x squared, 3 times 1 is a positive 3. So my final answer is x to the third plus 3x squared plus 1x plus 3. And that's it.